Hey everyone, in this lesson we are going to be exploring optimization methods with real-time lighting inside of Unity. So this scene right here I have with dozens and dozens, probably even 100 or so real-time lights. Now the performance is okay, but with a scene this small with very simple low poly meshes, we should be getting better performance than we are right here. Now, what are we actually doing in this scene? Well, inside of the scene, we have a number of different lights, okay? And if you notice, all of these lights here are casting shadows. They're different colors, different sizes. These street lights here have two different light sources, spotlights, point lights, all casting shadows. And generally, that is something you want to avoid, okay? Because right now, if you'll notice here, inside of our game view, everything looks fairly fine, but if you look closer, you'll notice that some of these lights are not rendering at all, okay? Each of these blocks have like a green light here, whereas up here there is no green light. These street lights over here aren't showing lights either, so what is going on? Now, the reason why that's happening is because the default rendering path for Unity has a cap on how many real-time lights you can have visible at one time. And in fact, if I get my main camera here, and if I go ahead and let's just say I drag it forward like this, you can see that the lights that are closer to the camera are going to begin popping in, while those further away are going to basically disappear. And that is just Unity's way of making it so that we are not rendering hundreds of real-time lights at once and end up crashing our game. So, what are the ways that we can optimize this? Well, first of all, if we want a straight up doubling of our FPS, we can start by turning off shadows. Okay, shadows are one of the most expensive things that you can really have in a game because they require multiple rendering passes. They've got to be calculated, you've got to generate shadow maps and all of that, and it can be quite taxing on your system. So we could go ahead and go through and disable shadows on all of our lights, or what I would recommend is if you are having a game where you have a player walking around, probably have shadows on for lights that are closer to them. But for lights that are up on these buildings here for more accented visuals, we can turn those off. But just for an example, I'm going to go ahead and turn off all of our shadows here. So if I hop into game view, what I'm going to do is I'm going to go over to where I have my URP render pipeline asset right here. And what I'm going to do is down here in the lighting section, I'm simply going to disable cast shadows on my additional lights. Now you can see if it's on, if it's off, there's a small difference. And if you are creating a sort of top-down isometric game like this, where you have a very distant camera from your game world, then really you probably don't need shadows at all. Your main light, which acts as a sun, you could probably still have that on, but for everything else, I would recommend having no shadows on them, as the difference is not even that noticeable. And honestly, a nice little hack is if you have screen space ambient occlusion enabled, that in many ways can sort of simulate shadows a bit. As you can see when I turn it on and off, I'm not too sure how it's going to appear in the video, but it does give sort of connecting edges a bit of that darkness to sort of simulate, I guess, like depth and shadows and stuff like that. So SSAO is a way of sort of faking shadows in a way. It's not exactly the same thing, but it can sort of simulate that at a distance. But yeah. So we're going to turn off shadows here, and if I press play, we can see that our performance is going to be quite a bit improved. So what I'm going to do is actually I'm going to enable them while we're playing the game. So you can see right now, shadows off, we're at about 200 FPS. If I turn them on, we're going to jump down to about 100. So you can see that shadows are basically doubling or halving our performance if they are on compared to if they are off. And if we have a game like this, where we're at a distance, doubling our FPS for a very minor reduction in visual quality, I think is 100% worth it. Now, we have one more issue with our real-time lighting, and that is the fact that the lights in the background here are not actually on, okay? They're not visible. Now, that is generally something you want. You probably don't want to have thousands of real-time lights appearing at the same time, but if you do, then you can choose to go down an alternate rendering path that Unity provides. So let's have a look at the different rendering paths that Unity has. So what we're going to do is we're going to go to our renderer asset right here, our universal render data. If you're using HDRP, then you can find your respective one of these. But if we go into the inspector now, you'll see here we have rendering path, and this basically determines how these objects are rendered to our screen. And the rendering path is really, it has a few minor things it changes in terms of like how it renders transparency and shadows and stuff like that. I recommend you read more up on it, as there are some very fine details between them. So the options we have here in UDRP is forward, forward plus, and deferred. If you're using the built-in version of Unity, then you'll be on the forward rendering path, and you'll actually have to go to a different window in order to modify this. I believe you have to go to your graphics settings inside of the project settings window. And we can actually switch between these live. So if I switch over to forward, you'll see that all of a sudden we have even less lights. Okay, none of these buildings here have their window lights on, and that is because the forward rendering path has an even greater limitation on how many real-time lights it can show at once. If we swap back over to forward plus, you'll see that we are rendering much more. And generally in the newer versions of Unity, I think forward plus is the way to go, as overall it has a pretty good balance between forward and deferred. Now, what deferred allows us to do is it allows us to basically render as many real-time lights as we want. Okay, so we don't have a hard limit. If we wanted to have thousands of real-time lights now seen, it is going to render every single one of those. Now, the downside is that there is a bit of an overhead. So if, for example, you have quite a small scene with a bunch of lights, you're going to actually notice your FPS drop a bit, okay? And in fact, if we press play, we might in fact see that right here, okay? And yet you can see actually our frames are kind of dropping a bit. Even if we go ahead and disable the shadows, we are still not reaching that 200 FPS limit. Now, the reason why is because with deferred, even though it allows an unlimited number of lights, there is sort of a point where if you don't have enough lights, or if you're not utilizing it to its fullest potential, then you're not going to get the benefits, okay? I recommend you do more research on how these rendering paths differ, as there are many different ways. For example, on mobile games, deferred is not really a standard. You really want to stick to forward if you're on mobile devices, but if you're on PC and you're really only targeting higher end devices, then deferred could be a great option, okay? So that is a look at the different rendering paths as well as real-time lighting. Now, if you're having a normal scene like this, where you have lights and it's static, then I'd honestly recommend baking most of these lights here, because if you are having a static level that is set at night, you do not need all of these real-time lighting. And in fact, if it's baked, you can get much more high fidelity in your lights. You can get nice light bounces, you can get just overall better visuals with light baking. Whereas if you're having a scene that is perhaps dynamic, maybe you want a day-night cycle, then baking lighting for that is a more difficult thing. So in that case, I would recommend using real-time lights. But do be aware that lighting inside of game engines is one of the most taxing things on your performance, especially if you are casting shadows. Now, in UDRP, something we can also do is change the shadow resolution. So, for example, if we go over into here, let's go ahead and select this yellow light right here. Now, if we go over to the inspector, down where we have our shadows, you'll notice that we have a resolution. Now, this can change. So right now I have it set to low, because otherwise we will have errors popping up here, basically telling us that we have either too many lights or our shadow maps are going over the texture limit, okay? But if I switch this over to high, you'll notice that our shadows are far more crisp now. And your initial reaction is probably to make every single light in your game emit shadows that are of a high resolution, which, for things that are closer to the ground and closer to where the player will be walking around, that's probably a good idea. But generally, if we have a light, for example, this blue one here, first of all, this probably doesn't even need to be a shadow caster, so we could actually just turn off shadows for this one, and you wouldn't even notice a difference. But for example, in the street here, where we have all of these lights, if, for example, you're creating a racing game, you don't need to have hard shadows, okay? Or you don't need to have crisp shadows. You can have the most basic shadows, or perhaps even none at all, okay? So it really depends on what sort of game you're making, but those are just a few examples of how to optimize that, so thanks for watching. Hey everyone, in this lesson, we are going to be exploring baked lighting inside of Unity. Now, one of the alternatives to having real-time lighting in your scene is to have what is known as baked lighting. Now, baked lighting is basically where we run all of the lighting calculations beforehand. So when it is running on another device as an executable, the lighting is not being calculated, okay? Because we are going to pre-calculate the lighting on our machine so that, for example, if you published a mobile, they will not be wasting processing time trying to generate the lights and the shadows and that sort of stuff. So, baked lighting is very powerful in that way. And one other benefit that baked lighting gives us is much higher fidelity. And by that, I mean baked lighting allows us to have light bounces and indirect lighting. So for example, you can see we have this here, for example. Okay, we have this red light, it's shining down onto the ground and it's making the ground red, as you would expect. Well, in real life, light bounces around. So in real life, this light would bounce, hit the floor, hit up underneath this table, underneath this awning here. Whereas right now, it does not do that because real-time lighting inside of Unity is only direct lighting, meaning it is only going to light the surfaces it directly hits. And that is, of course, because real-time indirect lighting is very expensive. It is possible with ray tracing, but that is an entirely other aspect of Unity graphics that we're not really going to look at in this course. But yeah, essentially, baked lighting allows us to calculate the indirect light bounces. So we could then have a bit of red underneath the table as the light would bounce up off the floor and hit the bottom of the table here, which is pretty great. If you want to have higher quality visuals, light baking is a great option. Now, the downsides of baked lighting is that since we are calculating all of this data beforehand, that is going to take up file space. Now, depending on how big your scene is, how many lights you are using, the quality that you want from it, it can get quite large. Some scenes could be a gigabyte or so in light mapping data, which if file size is an issue for you, then I would recommend not light baking. But if you're able to sacrifice, a few hundred megabytes, maybe even a gigabyte for your light mapping data, then it is a great option to explore. And there are also many ways of reducing the file size and sort of balancing it between quality as well as performance in that way. And another thing is that since we are also saving these as textures that are going to be applied to our scene, it is going to take up space in memory as well. But it's not that much, and generally the performance should be actually improving upon having baked lighting. So let's have a look at how we can set this up. What I'm going to do is I'm going to go first of all and set up our scene to basically allow for baked lighting. Now there are two things we need to do. If we want an object to be included in the baked lighting, we first of all need to make it static. The reason why is because a texture is essentially going to be applied over the static objects that is going to store the lighting data. And if we have a dynamic object that's moving around our scene, we don't want to bake lighting data onto that. Otherwise, it'd be very weird to see a blotch of shadow on it, and as it rotates and spins around, it sticks to it, okay? So I'm going to begin by making every object in my scene here static. So I'll select this parent object, which contains all of these models. I'm going to go to the top right corner of our inspector and enable static, okay? And there we go. Now, the next step is going to be setting it up so that our lights are also going to be included in the bake. So what I want you to do is go through all of your lights in the scene and do this. We're going to select our light. Then over in the inspector, we want to go down to where we have our light mode. Now, by default, it should be on real time. And we have three options. We have mixed and baked. Now, baked means it is only going to bake this lighting, okay? So when we bake it, it's going to calculate its light rays, its bounces, and all of that. Mixed is sort of a mix between real-time and baked, meaning it is going to be included in the bake, but all dynamic objects are also going to get that real-time lighting. Now, for things like these windows here, it's probably fine to just set this to be baked, whereas if you have a sun and you want it to cast shadows on the player as they move around, something like that I would recommend switching over to real time, as you might want those baked shadows and light bounces, but also you want to actually have shadows that move with the player and perhaps other objects that are also moving around in your scene. So go through, switch all your lights over to baked or mixed, and I'll be right back. Okay, so I've gone ahead and changed all of my lights over to baked now. Now let's have a look at how I can actually begin setting up our baked lighting. So what I'm going to do is I'm going to go over to the lighting window. We can get that by just going window, then down to rendering, lighting. And in here, we want to go over to the Scene tab. Now in the Scene tab, we want to go down to where we have our lighting settings, and we want to create a brand new lighting settings asset, okay? This is just going to contain all of the settings here, so that if we want to basically copy and paste them into another scene, we can simply just use the same file. Now, down here, we have a lot of options. And when it comes to light baking, it can be quite overwhelming with how many different options and toggles and values there are to change. But generally, the default settings here should be good, although it is really going to depend on what type of scene you're making, how big it is it indoor, is it outdoor, how many lights you have. So this is really just going to be room for experimentation. And in many cases, there is not one fixed list of settings that you should apply, okay? Again, it's going to really depend on what sort of environment you want to bake. Now, what we're going to do is we're going to skip over real-time lighting, skip over mixed lighting, as these generally you're not going to be changing, and instead we're going to go down to the light mapping settings. Now, here in light mapping settings, we first of all have to choose what type of light mapper we are going to use, and there are two different ones. We have progressive CPU and progressive GPU. This is basically going to determine how the lighting is going to be generated. Is it going to be generated on your graphics card or on your processor? Now, if you have a pretty good graphics card, I would recommend switching over to progressive GPU, although there are certain limitations and differences between them. You can do further research on those if you wish, but generally, if you have a pretty good GPU, I recommend switching over to progressive GPU here, okay? Now, down here, we begin with these three different sliders, and these are our samples, okay? And this is basically going to determine how long it's going to take to generate our light map, as well as the quality that we are going to get. So, direct samples is basically going to determine the resolution or the amount of data that each light is going to produce for direct lighting, okay? Direct lighting is basically where a light emits onto a surface. So this light right here we are seeing on this wall here is direct lighting. And the higher the direct samples are, the higher quality that lighting is going to appear. Indirect lighting, for indirect samples right here, is going to be the lighting, like I mentioned before, that is bounced and sort of bounced off from one surface to another, okay? Now that is a pretty high number just because when one light bounces, it can bounce in all sorts of directions, okay? So that's why this is fairly high. And then environment samples basically determines the amount of lighting data it is going to get from the skybox, essentially, okay? From the surrounding environment. Now, we can go ahead and start modifying these values. Now, by default, this is what they look like. If you have a indoor scene, you probably want more indirect samples because you can have light bouncing off walls, ceilings, floors, etc. Whereas outside, you kind of got floors, maybe a couple walls, but mainly an open sky. So in fact, we can reduce our indirect samples a little bit here if we wish. Direct samples, we'll probably just keep that at 32. And environment samples, since we are working with a sort of nighttime scene here, I'm actually going to go ahead and bring that down quite a bit, just because we don't need that. Whereas if you're working in an outdoor scene with a sunny sky, maybe clouds, something like that, I recommend keeping that up at its default value. Max bounces down here is going to determine the maximum amount of bounces a light ray can do. Generally, we just want to stick that to be 2, one bounce here, hitting the floor, another bounce up here, and then another bounce down here, hitting the floor again. That's enough generally for most scenes, although if you have perhaps a very small environment where you want the highest quality possible and you don't have that many lights, then more light bounces could be an option. Now, in the next lesson, we are going to continue to go over these settings and then begin generating our lighting. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be continuing on with looking at our light map settings, and then we're going to begin baking our lighting. So let's now go and look at what light map resolution is. This is basically going to determine how many texels per unit we are going to have. Now, a texel per unit basically means, in Unity, for example, we have meters or units, okay? So basically 1 meter is probably going to be the length of this table right here. And this basically determines how like what resolution, okay? Think of it as pixels. So if we divide this up into 40 different sections, that's essentially going to be the lighting resolution, okay? If it is lower, we're going to have much more blotchy looking lights and shadows. The higher this is, the much crisper the lighting and shadows are going to be, but of course, the longer it's going to take and the bigger the file size is going to be. Now for us, I reckon we just keep that at about 40. In fact, since we are having an outdoor environment and the camera is fairly far away, we could actually probably bring that down to about 30, okay? Light map padding, this basically determines how many texels is going to be separated between the baked light maps on the texture. We'll just keep this at 2. The max light map size is basically going to be the size of the individual light map textures. This is by default just set at 1024, which we'll keep. A fixed light map size, we're just going to keep that disabled. We're going to keep most of these settings as they are. Light map compression basically determines how much compression is going to be applied to these textures, okay? Now, when it comes to compression, if you set this to none, that means it's going to have all the raw pixel data in there. It's going to look the best, but it's going to be a large file size. Setting this to high quality means that the file size is going to be, it's going to slightly be reduced, but it is going to have very little artifacting. Whereas if you want the most compressed and the smallest file size, we can switch this to low quality, which is going to reduce our file size, but we're going to have lots of artifacting in our shadows and in our lighting. So I'm just going to switch that over to high quality for now. Ambient occlusion. With the render pipeline I'm on right now, I actually already have SSAO enabled, but you can actually build that into the light map itself, which is pretty handy here. And then all these other settings here, we're just going to keep as they are. Now, what we're going to do is simply go down to the bottom here, and we are going to click Generate Lighting. Okay, now depending on the size of your scene, this could take a couple minutes, it could take tens of minutes, it could take an hour, a couple hours, it really depends. So I recommend we just let this run for a bit. If you want more information about how this is going, we can click down here where it says Global Illumination, and that is going to open up the background tasks window, okay, so we can see it going up. So basically, let your scene bake, and I'll be right back when it's complete. Alright, and we are done. So, at a first glance, the scene may look very similar, but if we start looking at it a bit closer, you'll notice that the lighting is actually improved quite a bit. So, we got our red direct lighting on the wall here like before, on the umbrella, on the table, but if we look underneath, you can see here we actually have the indirect lighting applied, okay? No longer is it just black. We now have the lighting bouncing off the floor and then up into the table here. And in fact, this shadow here has a tinge of red as well, so it bounced back down onto the shadow here. Same thing for under the umbrella. Even the table here, which is in shadow, is slightly more red due to the fact that the light is bouncing around. And if we look around our scene here, you can notice that it looks okay. We got the lighting here working fine with the bouncing, it looks great. But when you start looking over here, for example, we have very small areas where the light is bouncing. It can, sort of show its flaws, okay? So here, for example, where we have the sort of shadowed area, that doesn't look the best. Over here where we have the lights blending into one another, that also is, not looking the best here. And that is mainly due to the settings we have done here, okay? It didn't take me that long to actually generate this. So what I'm going to do is I'm going to basically try and generate this again, but with higher quality settings. So what am I going to do? Well, I'm going to go ahead and increase the direct samples a little bit. I'm going to increase the indirect samples. I'm going to bring that up to about 512. Environment samples, we can bring that up a little bit as well. It's not going to be too important. Max bounces, I'm going to set to 3, so we have even more light bounces going on. Light map resolution, I'm going to bring that up to about 60. Light map size, I'm going to set this to be 2048, just so we have higher resolution textures as well. Okay, so this is probably going to increase the performance, or not the performance, but increase the file size by quite a bit. So let's generate this and see how better it looks. Okay, and there we go. Now, the file size is about 200 megabytes. Down here we can see 213 megabytes. And the quality has improved a bit. I am noticing that the shadows are crisper, first of all, since we have an increased resolution. But we're still getting this artifacting over here. Now, I think this somewhat has to do with the fact that this model here is basically just a thin plane, which could be causing these issues, so do keep that in mind. But yeah, everything else, it looks fairly nice. The shadows, like I mentioned, are pretty crisp. Now, if we go out here, you'll notice that everything, again, looks fairly nice. One thing you may also notice with this, especially in like nighttime scenes, is that you will get these weird artifactings on your meshes here, okay, that are catching a bit of the stray lights. Now, this can be solved by increasing the samples, increasing the light map resolution, maybe even the light map padding, as well as some of the light could leak over from other textures. But something else that you may also be running into, an issue, is the fact that your lighting looks absolutely nothing as it should, okay? You might have shadows streaking up your walls, lights going off on weird angles, and that can be due to the light map UVs not being correctly set up on your model. So to fix this, you want to go over to your models, select all of the models that you want to basically fix, so essentially all of them, I'd say, then go over to model in the inspector, and then down here at the bottom, you want to enable generate light map UVs, okay? And then click apply. This is basically just going to make it so that the UVs on your models are going to basically fit into the standard Unity has for generating UVs, okay? As if you're creating your own models in Blender, for example, they can end up looking quite odd when you start generating your lighting, okay? So do be aware, if you are having issues with that, simply enable generate light map UVs, generate it again, and it should be looking normal. Okay, so that is a look at baked lighting inside of Unity, and if we go ahead and press play, we can look at our performance, which should be far improved from if we're using just traditional directional lights, and as you can see, our FPS is pretty high. So yeah, thank you for watching.